Let's look at some examples, just to make sure that we get it right. We begin with move 0 extension. Here we have two different examples. In each of those examples, we put some number inside AL, and then we extend it into CX using move 0 extension. Hence, actually, we extend a number of size 8 bits into size of 16 bits. The leftmost container, CX, is larger than the AL container. CX is of size 16 bits, however AL is of size 8 bits. In the first example, we extend a number that begins with 1. This number could be unsigned. The processor doesn't care about it. If you chose move 0 extension, it is going to extend it with 0. So we can see that in both cases, even when the highest bit is 1, or even when the highest bit is 0, move 0 extension is always going to extend the number with 0. Move 0 extension is a pretty simple instruction. It doesn't really care about sign or stuff like that. It just cares about 0 extension. Let's take a look at the other instruction, move sign extension. Move sign extension is more sophisticated. It checks the first bit. Move 0 extension doesn't do it. It always uses the 0 extension. However, move sign extension first checks the highest bit, the MSB, and the extension is going to be according the highest bit. If the highest bit is 1, we are going to have extension made of 1. If the highest bit is 0, the extension is going to be made of 0. As a summary, move 0 extension always 0 extends, and move sign extension decides on the extension according to the argument sign. Let's look at other ways to sign extend. I remind you that we mentioned about 6 instructions, right? Let's go back for a moment. We've covered so far move sign extension and move 0 extension, and we have those to cover yet. Some simple look on those two instructions, which are mostly pretty simple. First, CBW, convert byte to word. What is word in x86? It usually means 2 bytes. Word can mean many things. Maybe if you are a high-level programmer, word might mean something different for you. But usually, when we speak in x86 assembly, when we say word, we mean 2 bytes. 2 bytes together. So byte is of size 8 bits, and word is usually of size 16 bits. That is the usual meaning of this expression, word. CBW has no arguments at all. You just use the instruction like this, no arguments. And its sign extends AL to AX. Another instruction which is pretty similar is called CWDE. Convert word to double word, and the E stands for extension, I think. This instruction has no arguments too, and this one sign extends AX to EAX. So the first instruction extends 8 bits to 16 bits, and this instruction extends 16 bits to 32 bits. Let's look at some simple examples. First, we initialize AL with this number, and I picked this number because it has the first bit 1. So it is considered to be a negative number. I picked it so we can see something interesting in the extension. When we use CBW, convert byte to word, we are going to get this result. CBW checks the highermost bit, the MSB, and if it is 1, then it extends with 1. If it was a 0 bit, then the extension would be made of zeros. So this instruction extended AL into AX, and it considers the sign. The next instruction, CWDE, extends AX, which is currently this number, into EAX. So it extends 16 bits into 32 bits. I remind you that these two instructions understand sign. They sign extend numbers. They don't just add 1 or 0 arbitrarily. They check the sign of the argument. If the argument is positive, they are going to extend it with 0. If the argument is negative, which means highermost bit is 1, they are going to extend it with 1. Let's look at some other two instructions, CWD and CDQ. These instructions allow you to extend numbers in a way that involves the EDX register too. The last two instructions, they only use the EAX register. But these two instructions, they also involve the EDX register. So you can extend further. You can extend your numbers to be pretty large. You probably also remember that EDX register is pretty important in instructions like div, because you usually actually divide EDX, EAX by some number. So it is pretty reasonable that you might want to extend the number beyond EAX to EDX2. Let's begin with CWD. Convert word to double word. You might be surprised because we have already seen an instruction that had a very similar mnemonic. We had the CWDE instruction. It seems to have the same name as CWDE, but it does something different. This instruction has no arguments, and its sign extends AX to DX AX. So actually it extends 16 bits to 32 bits. This instruction, for example, doesn't affect the highest part of EAX. It doesn't touch the highest 16 bits of EAX. It only affects AX and DX. CDQ. This instruction is pretty common inside assembly code. You are going to see it pretty much next to every div instruction out there. So what does it do? It converts double word to quad word. Let's just remind ourselves what does these expressions mean. Double word means 32 bits and quad word means 64 bits. Why is that? I remind you that we consider word to be 2 bytes. So double word means 4 bytes and quad word means 8 bytes, which is 64 bits. CDQ has no arguments and its sign extends EAX to EDX EAX. So actually it extends 32 bits to 64 bits. Some very simple examples regarding those instructions. In this instruction we move this number into AX and then we use CWD, which is convert word to double word. This instruction is supposed to extend AX into DX AX. And indeed, the result as expected is extension of AX into DX AX, and DX is filled with 1s because AX was negative. it begins with the bit 1. It has 1 as the highest bit. Let's look at another example. We move this number inside EAX, and then we use CDQ. I remind you that this number is positive. If we represent it in binary, then the highest bit number 31 or 32, it depends where you begin your count, is going to be 0. So after using CDQ, EDX will contain zeros because this number is positive, and EAX is left unchanged. Another example. This time we put another number inside EAX, but this number is negative. It begins with the bit 1. Therefore, after the CDQ instruction, EDX is going to contain 8 Fs. EDX is going to be consisted only of bits of 1, and EAX is left unchanged.